Hi, good morning to one and all. In previous class, we discussed about the forces and power requirements in rolling process. Okay, in today class, we will discuss on rolling defects. Okay, during the processing of rolling operation on materials, some defects will occur. Okay, due to the some forces or based on the type of material and type of loads, some defects will occur. We have to rectify by using some remedies. We will discuss based on the defect. We will discuss the remedies for those defects. Okay, first of all, to understand the causes and remedies of rolling defects. Okay, why it will cause that defect. Okay, what are the different types of remedies for this problems? Okay, total the rolling defects we divided into two types, that is surface defects and structural defects. Coming to surface defects, here surface defects include rusting, scaling, surface scratches, surface cracks, pits left on the surface of due to subsequent detachment or removal of scales which may have been pressed into the surface. Okay, during the rolling process, some surface cracks will be occur. Okay, or scratches due to the slag formation on the material and removal of rust or slag on the material. Okay, due to that the marks will form on the material. It will form a surface cracks. Okay, due to all these reasons the surface defects will occur. Okay, next, coming to structural defects. Structural defects are more important in rolling process. Some of these difficulties are that is wavy edges, zipper cracks, edge cracks, center split, alligatoring, and folds and laminations. These are the different types of structural defects will form in rolling defect. Okay, we will discuss one by one. Coming to wavy edges and zipper cracks. In these defects are caused due to the bending of rollers. Okay, bending of rollers under the rolling pressure. Okay, already we discussed during the processing of the rolling process on hard materials. What happened due to the hard materials? That we have to apply the more amount of forces on the workpieces. Due to this, what happened? The rollers will bend due to the hard materials. Okay, that due to that reason, the rollers will tends to bend. Due to this, the wavy edges are formed. Okay, for that case, we are using three-way rolling mill, four-high rolling mill, like that we are using. Okay, a roll can consider as a beam supported in its stand. Okay, under rolling pressure, the roll deflects in the manner as shown in figure. Next, consequently the work material becomes thinner and two edges are thicker in the central portions. Okay, the edges of the rollers are thicker and the center portion is thicker. Okay, edges is thinner and center is thicker. Observed in diagram. Here, in other words, it means that the material becomes longer as measured along the edges than its center. Okay, the measured length is longer in edges and compared to the center. This causes tensile stresses in the center and compressive stresses in the edges. Okay, the former causes zipper cracks in the center and the later causes wavy edges. Okay, observed in diagram. Here, coming to first diagram, that is diagram A. Here the black color indicates the workpiece and the above and below are rollers. Due to the passing of workpiece on between the rollers, what happened here? The rollers tends to bend. Due to this, the wavy edges are formed. In between the distance between the two rollers at the center is more compared to the edges. Here the edges will be tends to the thickness will be reduced compared to the center. Observed in diagram B. In center, the tensile forces are applied in the center and the edges will be applying compressive forces. Okay, due to this cause the wavy edges are formed and zipper cracks in the center portion observed in diagram D. And okay, for this case we have to use a remedy. For that roller we have to change the design of the roller. In the center we have to use a convex shape. For by modifying the design of the roller above and below, we have to overcome these effect observed here. The workpiece, the thickness is uniform from center to edge. Okay, by using this we have to overcome the wavy edges and zipper cracks. Okay, the remedy for zipper cracks or wavy edges lie in the provide a camber to the rollers. Camber is nothing but we have to changing a design of a roller, that is the center of the portion is maximum and compared to the edges. Okay, they are made slightly convex in the central portion to offset the effect of the deflection under loading condition. Okay, next coming to edge cracks and center slip. These defects are caused due to non-homogeneous plastic deformation of metal occurs in the width. Okay, non-homogeneous plastic deformation due to the stress on the workpiece. What happened? Will not uniform on the total. Okay, workpiece. Due to this cause, the edge cracks and center split will be formed. Here, as the workpiece passes through the rolls under the rolling pressure, its height decreases. Okay, while its length, what happened? It will increases in length. In the same way, the width also in sometimes it will increases, known as lateral spread. That is increase in width also takes place, is known as lateral spread. Okay, however, the lateral spread is more towards the edges than the it is center, as there is a little resistance to the lateral spread towards the edges. Due to this, what happened? The edge cracks and center split will be happen. Okay. Next, in the center lateral spread is resisted by friction and adjacent layer of the material. Yes, due to the friction, the center lateral spread will be resisted. Okay, for that case, the length will be increased compared to its lateral dimensions. Okay, next, hence decrease in lateral spread in the central portion of the work material results in greater increase in the length this region as compared to its edges. Okay, here the lateral dimensions will be reduced and length will be increased. This effect will show in figure observed in diagram A. In center, what the arrows indicate in the tensile forces, and the two edges of either side of the center, that is it is represented in arrows in compressive manner. That means that here in center the tensile forces will act, and in edges the compression forces will be happen. Okay, next, due to this cause, what happened here edge cracks will be formed. Okay, in some cases and center split as shown in figure C. Okay, due to this the edge cracks and center split are formed. Okay, coming to it can be realized that under the such non-homogeneous deformation of work material, the edges experience a tension at the center of the portion, and due to this continuity of material and the central portion experience a compressive stress. Okay, such a distribution of stress may result in edge crack or in the severe cases. Okay, the splitting along the central portion. Okay, these are the causes for edge cracks and center split. Okay, next, coming to alligatoring. In this, as a point out earlier, rolling entails a reduction in the height with consequent increase in length. Okay, due to this the alligatoring will happen, but due to the friction present at the interface of the rollers, that is upper and lower surface of the workpiece. Okay, the elongation of the top and bottom surface is less than the material located at the center of thickness. Due to this, what happen? The length will be increasing in edges will be reduced compared to the center. Okay, if condition becomes severe, what happened? It may cause a defect called alligatoring, that is rupture of material along the length into an half of the lower half and upper half. Okay, the open mouth of an alligator, that is it will layered in top and bottom surfaces like that. It will be defect is occur. The defect is shown in figure. Okay, observed it is in diagram mentioned, that is without defect. Whenever the workpiece is paused in between the two rollers, what happened here? Alligatoring is formed, that is here is known as arc of contact, this point to end point. Next it is upper roller and bottom roller. It is aluminum slab. Whenever it is paused in between the two rollers, what happened here? The bottom and top surface will be disattaching. Okay, due to this, this problem is known as alligatoring. Okay, next coming to faults, the defects is encountered when the reduction per pass is very low. Okay, uh, that is the pass per reduction is low. In that case, the faults will be happen. Okay, next coming to laminations. Laminations means layers. Okay, next if the ingot is not sound and has a piping or blowholes during the production of steel or in casting process, and during rolling they do not get completely welded, that is the piping has got oxidized material or non-metallic inclusions, it will results not get welded. Okay, it will cause a defect called laminations. Okay, next very often in this ingot there are non-metallic inclusions. During the rolling they will get lengthened along with sound material. This may also cause laminations. Okay, next these defects can only be remediated by discarding the portion of the ingot where piping and other defects are present by selecting the good metal portion for rolling. Okay, like this we have to overcome defects occurred in the rolling process. Okay, thank you.